Okay, so I think it's time. So good afternoon, everyone, and welcome to the NLP seminar organized by AI Sweden and RISE. Today, we're very happy to welcome Iryna Gurevych, a professor at the Technical University of Darmstadt, where she is the founder and director of the Ubiquitous Knowledge Processing Lab. Iryna has a long and distinguished career in NLP with over 350 scientific publications on a broad range of topics. She is a fellow of the ACL as well as of ELIS, and she is currently also the vice president of ACL, the Association for Computational Linguistics. And today she's going to talk about a very timely and important topic, namely how to combat misinformation using NLP. And now, without further ado, Iryna, we're delighted to have you here. The floor is yours.
Thanks a lot, Joachim. I'm delighted to be with you today. I'm not saying to be here today. My talk will be about detecting, debunking, and communicating about misinformation with the help of NLP. And as you can see, I was working on my slide until last minute, literally. So I originally had the title, Detect, Verify, Communicate, but then I decided to change it. And if you listen carefully to my talk, you will know why by the end of the talk. Just to have some introduction, I'd like to start with a dialogue. And we have heard plenty of such dialogues in recent years about the vaccination. The vaccines are unsafe. My uncle died after getting the shot. What study X proves they are safe? That's the truth. Well, that's not my truth. So this image illustrates a disclaimer I would like to make in the beginning of my talk. So this talk is not about finding the truth. So very often after the talk, I would get such questions and people start debating, so what is true or not. So my talk is about how to use NLP in order to assist humans in evaluating complex information, but it's not about determining the truth. This is also work in progress. We have already published some parts of this work. I will indicate it during the talk, but some of them are yet preliminary and we still work on them. So rather than presenting solutions in some places, I'm just discussing open research questions and potential direction. And I'm very much interested to take your feedback about these ideas. So to start with, I have an example, which is a realistic example taken from our work in progress, where we construct a data set with tweets and scientific articles that people provide as evidence for a specific claim they are making. And in this example, we can see that a tweet spreads misinformation about coronavirus vaccines and a false cure. So this information might be easily consumed by the readers on the social network because the scientific study has, per definition, an air of credibility. So this is particularly dangerous about fake news. However, in order to know if the study really supports the claim, we need to go inside with the help of NLP techniques, and I will discuss this in greater detail later, and that will prevent us from bad consequences, like people taking wrong medicine after consuming such claims. So what is the current state of the art in fact-checking in NLP? This is quite a big field by now, so that's a popular topic, and there are many funding programs on that. So there's there are plenty of projects, and our current tools are effective, I would say, if we know what harmful content looks like, and if we have data sets to teach our models. So it's all about training data. If we have it and if we kind of know what to expect, then current NLP tools can help with this. However, it turns out that in realistic scenarios, we very often do not know what to expect. So fake news, as part of their definition, cannot be really anticipated, and they may be very much different from the misinformation we have seen in the past. So that's one of the research questions that I'm going to deal with. Specifically in my lab, we have three lines of work, and this line of work on adapting to novel harmful content efficiently is the first part of my talk, where we try to provide methods that can realistically help to detect misinformation as it appears, that is to find claims that needs to be checked. And the second focus that I will be talking about is verification, that I've decided to replace with the term debunking. So here we provide theoretical analysis of existing data sets, and we look at real-world examples of misinformation and analyze the research gap between what we currently do in NLP and what we should be doing in order to solve this problem in real life. And the last part of my talk will be about the communicative aspect of the whole business. In particular, we all know that it's not enough to have the right facts. So if we want to convince people to change their point of view, we also need to account for psychological properties of this communicative scenario, and we need to know how can we provide the right counter arguments in order to help people change their point of view. So that will be the last part of the talk. So let me start with the first one. In particular, this is about the work we are doing regarding the first step in the pipeline, that is detecting harmful content. As we all know, harmful content comes in a large variety of forms, and all the time new topics emerge that we have not seen previously in the training data. And in NLP, we know this problem as domain adaptation. Given current NLP approaches based on transformers, there are two main difficulties here. So first, we have problems arising from poor generalization to new data and overfitting on the one hand, and also low efficiency of transformers due to their expensive fine-tuning. So if we had to adapt them based on newly annotated data all the time. So our goal in this part of the work is to create an approach which is more efficient and generalizes better without expensive retraining. Consider this example where an existing model has seen harmful and neutral examples about COVID vaccines. So the harmful one is the government discriminates against an unvaccinated. They'll send us to prison camps and take away our rights. And the neutral one is vaccination reduces death and hospitalization rates. And when it's introduced to a new example, which is a completely different domain, that is the war in Ukraine, refugees from Ukraine face heavy discrimination in Poland. They are basically treated like prisoners with no rights. The model could struggle to determine the label because the topic is extremely different from the first one. And instead of retraining, our system would then try to aid the decision process by reminding the existing model of the most similar example it has seen before. So because the first example, the government discriminates against the unvaccinated, is highly similar to the new example about heavy discrimination in Poland, we can give a hint to the model that this is an example of a harmful claim, and this way we can aid the classification decision. The current state of the art in NLP and in our domain of fact-checking, of course, is transformer models like BERT. And these models are very powerful and effective in modeling different kinds of problems. But as I said, they are very expensive to use. Our group has created an alternative to transformers called sentence transformers, or SBIRD. SBIRD creates a semantically rich representation of text in form of dense, high-dimensional vectors, and we use transformer-based Siamese networks optimized via cosine similarity. And these vectors can be used to train simpler learners that are much cheaper computationally than transformers. So this approach is widely used in literature. It was published in 2019, and I think for this paper we have about like 3.8 thousand citations. So it's really like a tool which is widely used in the community. However, a major problem with SBIRD representations is that they are fixed and they are not optimizable for the end task. And that's where our new and ongoing work called SetFit comes into play. This is a joint research project between UKP, Intel AI, and Hugging Face. And SetFit optimizes an SBIRD model using a paradigm from computer vision called contrastive fine-tuning. We can use this updated model and reap the benefits of both transformers and cheaper learning algorithms. And in this way, SetFit makes sentence transformers a viable model for end-to-end learning. So the thing that was previously missing from the SBIRD framework. And here we can see how SetFit is competitive with GPT-3, a massive transformer model on the Raft few-shot text classification benchmark. So the performance is a bit better or a bit worse, but on average is quite comparable, though SetFit is much smaller and therefore much less expensive computationally and can be adapted easily in the new domains. SetFit is performant in the few-shot domain, but it reaches a plateau with more training examples, as you can see here. And just for comparison, transformer classifiers show quite a different curve because they're more expensive and they don't perform as well when we have less training data, but are very strong learners when we have more training data. And we need to retrain them for a large number of instances all the time, which is impractical in the domain of fake news. This is prohibitively expensive. So now the next question we are asking, can we use both SetFit and transformers? And can we use these tools in order to better handle and identify misinformation? We combine SetFit and BIRD into a single hybrid system. And since real-world data are growing all the time, we don't need to keep retraining expensive models. Instead, we can use our inexpensive pre-trained embedding models like SBIRD to encode new examples and compare them to the data that BIRD has already seen. This algorithm works as follows. In summary, we first optimize our embedding and classifier on a small subset of the data. We then embed new test data with the updated embedding model that we call SetFit1. We then do a similarity lookup. So you remember my introductory example where we looked at the most similar previous example. And we concatenate the most similar training and test examples together. And then we predict with the frozen transformer model, showing it the most similar example it has seen before. So as I mentioned, this work is still in progress. So there is a paper and archive, which I've cited on a previous slide. And we have a preliminary evaluation in the domain of hate speech. So here we compare two baselines, the cheapest method that you can see under SetFit1 plus KNN and the transformer. And we see that the cheapest method is fast, but the performance is the lowest in these experimental conditions with different number of training examples. And for transformer, it's exactly the curve that we have seen. So at first the performance is bad, but as we provide more training data, the performance gets higher. And then we have a pure SetFit, and the last line is our hybrid architecture where we combine SetFit and transformer. So that's the second cheapest method, and it gives the best trade-off in terms of effectiveness and efficiency. So with this, I would like to move to the second part of the talk, which is about debunking. This is about how we check claims and then verify or debunk them. To start with, let me show this statistics that have been computed on the basis of a fact-checking website called PolitiFact. So we took 20,000 claims from this website, and then we computed the number of false, mixed, and true claims in this fact-checking resource. And the main takeaway from this graph is that in the recent years, we are faced with some development in the number of false claims. So the amount of false information is increasing quite rapidly. So the practical implication is that the time resources of fact checkers are quite limited, and they are not able to manually check all of those false claims, and it becomes very important to prioritize their work so they can focus on the most important check-worthy false claims. So that's why NLP should also focus more on debunking false claims rather than looking at different types of claims, because very often the methods that we have would not transfer to the distribution of claims and their properties that we encounter in real world. So real world misinformation is defined here as non-true harmful claims that professional fact checkers deem important to verify. So the emphasis is on real world. So we are really interested in claims that have properties of fake news as we encounter them in real life, rather than artificially created statements used in the data sets. And there are two main characteristics to such real world misinformation. So first, it's the volume. So it can affect many people, right? So because depending on the statement, it may be the case or not. And also it should be relevant to the society. And given these two criteria, volume and relevance, fact checkers try to prioritize their fact checks and select the claims for fact checking. Now, I have 3 claims that are taken from NLP datasets. So one is Coldplay is French. The other is 500,000 sharks could be killed to make the COVID-19 vaccine. And the third one is Beat It is not a song by Michael Jackson. So all these 3 claims come from NLP datasets for fact checking. And normally in a face-to-face talk, I would have an interactive unit here where the audience tries to figure out which one is the real world misinformation. In a hybrid setting, it's a bit more challenging, but maybe we can vote or something like that. So if you think the first one is the instance of real world misinformation, you can just raise your hand in Zoom, for example, and in the audience. So first one is Coldplay is French. And the question is this real world misinformation? What do you think? If yes, then please raise your hand. So I have one hand raised in Zoom, not so much. Then thank you very much. The second is 500,000 sharks could be killed to make the COVID-19 vaccine. Who thinks this is an instance of real world misinformation? Please raise your hand. So I mean, many people maybe do not vote, but I have something like 10 hands. Thank you very much. And then the last one, Beat It is not a song by Michael Jackson. So who thinks this is real world misinformation? So yeah, so we have kind of like 5 people. So in Zoom, it's easier for me to measure than in the physical room. So it seems like, you know, in summary of this small interactive unit, most people think that 500,000 sharks could be killed to make the COVID-19 vaccine. And then the interesting question is, so why is it so? The nature of the second claim, 500,000 sharks could be killed to make the vaccine, is a bit different from Coldplay is French and Beat It is not a song by Michael Jackson. So first, it's kind of like could be killed, you know, it's a conjunctive mood and it has some numbers inside. So there's a lot of uncertainty associated with it. And in compared to the other 2 claims, which are more like straightforward short sentences, probably they could be checked against some large knowledge base more easily. Yeah, so just to conclude the discussion of this slide, so for those of you who might not be familiar with this area of research, the first claim and the third claim, Coldplay and Beat It claim, are taken from the most popular NLP data set for fact-checking called Fever, while the 500,000 sharks could be killed to make the COVID-19 vaccine is taken from ours, that is collected from Twitter, right? And yeah, by this fact, you can see that the current NLP is focused on somewhat simpler scenarios that you encounter in real life. And the example illustrates that the properties of the claims as we have them in the data sets do not correspond to those that we have in real life. Now we talk to fact checkers and we try to figure out what they actually do in their work. So suppose they have this claim about hydroxychloroquine. So from my initial example on a COVID-19 cure, so first of all, when they have such a claim, typically they cannot rely on some big database that states that this is not true, because there is no such document or article describing that the fact is not true. So what do they do instead? So they look where this information came from. Who is the source of this information? And in this particular case, the information comes from anti-science pro-Trump organization and from a known conspiracy theorists. And for humans, it would be important at this time to contact those parties for justification. Of course, computers cannot do it, but the human would typically call that party or contact them in some other means. And also the human would try to understand why the claim was made. So what is the reason behind that claim? And yeah, then they will look into the article that is provided as a sort of evidence for that claim, and the human would easily see that this article is not a valid piece of evidence here, because the article is dated with 2005, where there was no COVID, and it's about a different virus. It's about SARS and a different experimental conditions. So that's, in summary, how the fact checkers work. Now, what do NLP systems do? We usually have a claim and we have a big trusted knowledge base that we extract from a big corpus, and we try to retrieve some evidence and counter evidence, and basically we verify based on that, and then we come up with a verdict, and that works very well if we can verify known facts. So that means that we can rely on the evidence existing in our big trusted knowledge base. However, if we compare this to the workflow, which I've just described to you, we figure out that this does not apply to real life claims. So it turns out there is no counter evidence existing for them that we could find by looking up in the database. And that means, in consequence, that current NLP fails to account for novel misinformation due to a simple fact that if misinformation is truly new, there exists no counter evidence for it in scientific articles or other types of documents. And also another important observation that we make is that humans extensively use the source of a claim in debunking the misinformation. And fact-checking organizations consider the source of the claim to be the key to fact-checking as such. Their handbooks state that sources provided by the claimant must be included and assessed in the debunking process, while we don't have any such information in our current data sets. And in general, the question, how do you know that, is actually at the heart of debunking, right? So the humans have quite a different strategy as compared to current NLP. So now we introduce a theoretical analysis that we did. After knowing how fact checkers verify, we want to know how they refute actual real-world misinformation. And in order to find that out, we manually analyze 100 misinformation claims taken from popular fact-checking websites called Snopes and PolitiFact. And in the first step, we remove all claims that cannot in principle be solved by NLP because they either require multimodal reasoning or they require identifying imposter content. So as a result, we are left with 75 claims. So the first strategy that we find is the classical. So we try to find the evidence contradicting the claim globally, and during this process, we discard the source of the information, or maybe it's just not available. So for example, if we have a claim like Ron DeSantis was never asked about the coronavirus, we will look in the corpus if there is a statement saying that he has been asked for that. And a more challenging claim is Kathy Manning gave nearly 1 million to liberals. So in order to check this, we will look in our trusted knowledge base what kind of donations she has made, and for each of them we need to check if it goes to liberals, and then we need to aggregate all of them and compare with 1 million. And already this inference process is quite complex for current NLP, and most of the NLP approaches actually would fail because they cannot perform arithmetic reasoning. And relying on existing evidence in the corpus or knowledge base can help us to debunk 20 out of 75 claims. So the next strategy is that we use is the so-called no evidence assertion. That means after existing search, no evidence can be found that supports the claim, and the source of the claim is irrelevant or unknown. So for example, Nancy Pelosi's son served on the Burisma board with somebody. We don't find any counter evidence for this, and searching for evidence in different knowledge base likely results in the same misinformation, so we can refute this claim. Then the next strategy is non-credible source. So for this, we really need to consider the source, and if we find it not non-credible, we refute based on the source. So an example is the terrorist is cousins with former President Barack Obama. We detect that the source is a parody page, so we discard the claim. That is, we refute it. Then the next, and this is quite a big portion of the data, 35 instances from 75, is relying on local counter evidence, and it can be found only after knowing the source of the claim and what it is based upon. So here we again need the source, and we already know this example that I explained, where we can look up the evidence in the scientific article, and the study can be used as counter evidence to refute the claim. And also in another case, 500,000 sharks could be killed to make the COVID-19 vaccine. We find that the claimant's evidence assumes that the COVID-19 vaccines are made using squalene. Then we can check the ingredients of the vaccine, and they do not use this substance, so we can use this as counter evidence. So the conclusion is that by design, only 20 claims can be refuted based on current NLP fact-checking architectures, but mostly even those claims require complex reasoning and aggregations that we cannot well perform nowadays yet. And the majority of the false claims cannot be solved by design because it depends on knowing the claim's source, which is not part of our data yet. And that raises the question, how realistic are NLP fact-checking data sets in general? So what we did in this work is an overall analysis of the most popular fact-checking data sets. So you can see 16 data sets here that are commonly used in this area of study. And we found that 6 of them contain no real-world misinformation. So what does it mean? We have seen this difference between the claims from current data sets like fever and real-life misinformation. So their properties are very much different. So many existing data sets can be called by lookup of evidence in some textual databases, but real-life claims are much more complex. So for them, those approaches would mostly fail. And the remaining 10 data sets provide either insufficient or leaked evidence. So I did not have time to explain this in greater detail. There's a separate study on that. But what it means is that most of the data sets are constructed by crawling the web, right? So the documents are taken from the web. And in many of the cases, those documents are fact checks. So basically solving the data sets relies on the existing of fact checks, but this is a chicken and egg problem, since when we have a new real-life claim, there is no fact-checking website that has already checked that claim. So we cannot rely on that evidence being existent. Different to that, we rather need to collect small pieces of evidence and somehow put this together and reason over that. But this scenario is again not reflected in the current data set. So in summary, actually, there is no single data set that would correspond to the properties of the real life debunking of misinformation. So that's why we say that the future NLP research should look at how humans refute real world misinformation. And based on that, we need to construct more realistic data sets that capture the properties of this scenario. And by all means, future data sets should crucially include the sources where the information comes from to get a step closer to the real life scenario. And also they should use realistic evidence. So that means we should not use leaked evidence in our data sets, but we should filter that data out and try to perform a fact check in the absence of already verified information. And as already mentioned, there are all kinds of phenomena that the systems will need to cover. So for example, in order to solve this claim, we need to also be able to perform arithmetic reasoning and work with numbers and statistics and further reasoning capabilities. So this part of the work that I've just described to you has been recently accepted to the EMNLP conference, and it's going to be available soon in the conference, but the paper is already available for those of you who are interested, and also we provide all the analysis and the software underlying the study. Now to conclude the talk, I'd like to briefly talk about the last aspect of communication, because we also need to communicate our findings in a manner that is persuasive to our target audience. For example, we might want to convince anti-vaxxer to finally get vaccinated and potentially save human lives. So this is about the question how to apply the fact-checking results persuasively and how to combat misinformation convincingly. And I've already mentioned in the introduction to my talk that this is an interdisciplinary area of science, and here we need to cooperate closely with psychology and cognitive science. And this is joint work with the group of Stephen Lewandowski, who has an ERC advanced grant at the University of Bristol in this domain of anti-vaccination argumentation. So in this work, we jointly construct a textual data set of anti-vaxxer attitude roots, and also we perform text modeling to classify those attitude roots. What is an attitude root? Attitude roots are underlying fears, worldviews, and identity needs that sustain and motivate specific surface opinions. Let me give you an example. Suppose we have the statement, we can't trust information from big pharma about vaccines. So here, the first step would be to understand the attitude root of the person behind this statement. The attitude root here is distrust, and distrust is related to the perception of hidden motives, for example, vaccines only being made for profit, right? And it's a valid concern that a person could have, because vaccination is a big business, so it could be, of course, the case that big pharma are interested to sell vaccines, and therefore people are hesitant about being vaccinated. So after we understand the attitude root of the person making this statement, the next step is affirmation of the attitude root. So COVID vaccines were profitable for the pharmaceutical industries, and it's not nonsense to be skeptical about their motives. So now that we have confirmed the attitude root, the next would be to rebut it. And here we turn the attitude root against the anti-vaxxer and turn their argument on its head. It would be far more profitable for big pharma to keep selling us treatments forever rather than create vaccines. And scientists work hard to ensure that vaccines are safe, and such rebuttals would be more convincing because they address basically the hidden motive and the concern of the person behind this, but they turn it on its head. So what is important here? It is important that we look at the root of hesitancy. And when we have the facts for how well vaccines work and why they are important, we need to match the facts to the argument. That is, we affirm the people's attitude, and to be convincing, we understand why someone believes the false argument, and we form a counter argument that addresses that specific concern. So here I have some examples of the attitude roots that we consider in our data set and how they correspond to text. So we are already familiar with distrust, where the example is you can't trust big pharma for information about vaccines. Then there's conspiracy ideation. For example, Bill Gates created the vaccines to control me, or unwarranted beliefs. Natural immunity is better. Worldviews, fears and phobias, morality concerns, distorted risk perception, selfishness, epistemic relativism, reactance, and religious concerns. So these labels emerge as a result of manual analysis of many texts by cognitive psychologists. So that's their research in the project. And this way we were able to construct two data sets. The first data set was constructed by a comprehensive literature review of 20 years of psychological works on vaccine hesitancy and extracting text from the article at different levels. And the second data set is quite different in nature. We scraped it from the web by labeling fact-checking articles that rebut anti-vaxxer arguments about COVID-19. An interesting thing that we can see in this graph showing the label distribution over the two data sets is that it is somewhat similar in that distrust, fear and phobias and unwarranted beliefs are the dominant labels in both data sets. And now we move to the textual modeling, and the question is, can we use our tools like SetFit introduced in the first part of my talk in order to model and automatically identify attitude roots? So we experiment with SetFit compared against standard transformer classifiers on the second data set in this experiment, that is on fact-checking articles, because this data is more representative of real-world misinformation. And we use a random and majority class prediction as our baselines, along with a sentence transformer plus logistic regression. And we see that under the same experimental conditions, SetFit is able to outperform the transformer model. And then we, of course, ask the question, can we do even better? So here the question is, can we use the expert knowledge that we have in the first data set based on scientific articles and leverage this knowledge in order to identify the attitude root in fact-checking articles? So first we pre-train the same classifiers on data set 1, and then we freeze them and perform a zero-shot classification of the articles. And that means we simply ask those classifiers about the answer on the second data set, and we have some amount of knowledge transfer, but it's not really great. So then we ask the question, what if we perform a two-step fine-tuning where we first fine-tune on data set 1 and then we continue fine-tuning on data set 2, and we get much higher results in this setup, and this has a nice interpretation that we can prime SetFit with expert psychological knowledge from the first data set, and then we can identify attitude roots in our second real-life data set. So here we can see that despite quite an elaborated annotation scheme with 12 different labels, we have a nice separation of the classes in a 3D space. So to summarize my talk, I'd like to recap the contributions and our ongoing work in each topic. So first, I talk about domain adaptation to automatically detect harmful claims. And I've introduced a new method how we can adapt to novel harmful content efficiently. So this can be employed in realistic misinformation detection. In the second part of the talk, and now you hopefully know the answer to the question why I had to replace verify with debunk. We have analyzed existing NLP data sets for fact checking, and we compared this with real life conditions and pointed out research gap and future research directions in this area. And the last part was our interdisciplinary work together with cognitive psychologists, which is about how to respond and rebut false information by generating effective counter arguments. In our ongoing work, as I've already mentioned, we try to construct a data set on misrepresented science. So my very first example has shown a tweet that cites a scientific study, which cannot be used as a valid evidence for this tweet. So this case is quite frequent in social networks. So we construct a realistic data set of such cases. And another direction that is very important and we have started to work on is multimodal content, because a lot of misinformation nowadays comes in mixed modalities, for example, together with images. And I think in future, this will play ever more important role, and we need to provide data for doing research in this domain. So that's all. Thanks a lot for your attention, and I'm really looking forward to the discussion.